Okay, so let's talk about number systems today, or sets of numbers. When you go into your pre-calculus class, you're going to be talking about sets of numbers. And sets of numbers can kind of be thought of as a big set of numbers. This is all of your real numbers. Now, imaginary numbers are something else, but these are your real numbers. And real numbers are kind of broken down pretty simply into rational and irrational. So we'll jot those two up there. But one of the things that happens, and one thing I do different from my students, is I don't talk about these number sets first. I go back and say the first things that we discovered were how to count. So our counting numbers, also known as natural numbers. So natural numbers, counting numbers. Jot that down up there. So natural numbers, counting numbers, are just what they mean. It means counting. And these have been around for probably since 20 or 30,000 BC, if I'm thinking of my history of math class correctly. But this is just where we counted 1, 2, 3. And the numbers that we use to count, these are called Hindu Arabic numerals. And the reason they're called that is there's a lot of emphasis from Eastern culture on the number systems. And the Arabic nations kind of kept track of math during the Dark Ages, so that's one of the reasons for that. But counting numbers. In the old days, they used to use tally marks, like to count things, tally marks. Like this. But what happened was, nothing happened. They just didn't have a lot of things to mark tallies on. They used to use like wolf bones. They used to use rocks and things like that. So tally marks were one of the first ways to do it. Thousands and thousands of years went by, and this was great. This was for counting. This was for like how many sheep do you have, or how many goats are in your herd, and so on. And then later on, Eastern cultures, I believe, added the 0. Let me put that down here. So it's all the counting numbers, all the natural numbers with a 0 in the front of it. And those were called, what we call them today, our whole numbers. Because they realized we needed a symbol to represent nothing. I don't have any goats, or I don't have any ducks, or whatever the case might be. So the 0 came into play. And then, as accounting systems got ramped up a little bit, they had to say, hey, how do I say that I owe my neighbor 3 goats? Okay, so they came up with negative numbers. And these are typically what I call in my classroom. These are the number line numbers. I have a number line in my classroom, but number line numbers are the integers. So when somebody calls for an integral solution, they want an answer in this form. They're kind of restricting the domain just to number line numbers. So a negative could say, well, I have 3 goats in my herd, but I owe my neighbor 2 dozen eggs. Okay, so they had to, for accounting purposes, I think, come up with negative numbers. And then the last thing that they had come up with was rational numbers. So rationals are up here. So rational, the root word of rational is ratio, and a ratio is a fraction, right? It's just a comparison of two numbers, say A over B. So rational. So I always teach students, rational just means it's a fraction. Rational, ratio is the root number. There you go. So this includes all the numbers that are, this is an infinite set as well, but includes all of the numbers, say, in between 0 and 1. So this could be like a fourth, a half, 2/3, right? So there's an infinite number of fractions in between 0 and 1. So when we added all of these to our regular number line, we got what were called the rational numbers. So rational has the root word of ratio, and that's what rational numbers means. So after that, they said, some of the ancient civilizations were heavy into geometry. So they had to eventually come up with irrational numbers. So the first irrational number, I'll just explain. Irrational means you cannot write it as a fraction, so you have to write it some other way. All right, some of the more famous irrational numbers are, we've all heard of pi, right? Pi. Euler's constant, E, right, which is about 2.718, or just any radical that is not a perfect square, such as the square root of 2. It could be a cube root. If I had the cube root of 5. So these are called irrational because there is no fraction that equals these, right? So for example, when I type this into a calculator, the square root of 2, I would get about 1.414. But this does not equal this. This is a decimal approximation of this. So when your teacher says simplify, just leave it as the square root of 2. That's as simple as it gets. This is a decimal approximation. So and where this came into play was in like the ancients, they realized, they knew the Pythagorean theorem, and they said, hey, if I have something that's, say, 1 foot by 1 foot by 1 foot, or a mile by a mile, I can use the Pythagorean theorem to find out that that is the square root of 2. And this gave them quite a bit of trouble because it wasn't an exact number. There was no fraction that equaled it. I could write this out as possibly 1,414 over 1,000. And that would be a very close approximation, right? But it wasn't exact. It wasn't an exact fraction. So this is irrational numbers. So usually up until you get to like Algebra 2, pre-calculus, you're dealing mostly with this set of numbers here, the rational numbers. But then we get into some irrational numbers, and this is only real numbers. I'm not talking at all about imaginary numbers. Let me know in the comments down below if you'd like me to make a video of those. But this is just a quick guide to get you started. And like I said, I like to start at the beginning and say counting numbers. Then we added the 0. Then we added the negatives. Then we added the fractions. So that will hopefully get you started on your sets of real numbers. So if you'd like to help a small channel, like, share, comment, subscribe, and I'll keep making videos like this just because it's kind of a fun thing to do. Plus, I'm hoping that it's very helpful to the students who are watching. So until the next time, don't forget, math is not a spectator sport. You have to do math in order to learn math.